In this video, we will be looking at how to solve the indeterminate 0 raised to the power 0 and 0 divided by 0, and show how these two expressions have the same result. We have looked at 0 in detail in the first video of this series, under the 0 and infinity playlist, and we saw that 0 is not absolute, and therefore 0 cannot be equal to nothing, and that it is absolute 0 that represents nothing, which cannot exist in reality. So we define 0 as being equal to absolute 0 plus some uncertainty epsilon. In general, any number n must be written with the addition of some uncertainty because nothing is absolute. So n is equal to absolute n plus epsilon. Why is this so? Imagine you place a loaf of bread on a surface and pick it back up. You will have crumbs of that bread remaining on the surface, which means that you haven't picked up the whole thing that you placed there. But those crumbs compared to the loaf of bread are negligible, and so you conclude that nothing was left behind, when in fact there was. It is these minuscule quantities that we represent by epsilon, so that one loaf of bread minus one loaf is not 0, but epsilon. The number of crumbs that will be left when the action is done with one piece of bread is not the same as the number that will be left if we use 2 pieces of bread instead, or more. That is why 1 minus 1 cannot be equal to 2 minus 2, and so on. So, in general, n minus n is not equal to m minus m if n is different from m. You may ignore the crumbs, but when the action is done many times, like in a factory for example, you will end up with enough crumbs that can make up more than one piece of bread. This is why it is important to write numbers the way we have done. You should know that this residue theorem worked for any object in the universe, just that your naked eyes cannot see all of them. If this is your first time here, please press the subscribe button to follow updates on the development of this line of reasoning. And if you like the video, please show us by clicking the like button. Any number divided by itself is equal to 1, like so. Hence, n raised to the power m divided by itself is equal to 1. Indices tell us that dividing two things with the same base is equal to keeping that thing constant and subtracting the powers. So, n to the power m divided by n to the power m is equal to n raised to the power m minus m, and this is equal to 1. What about n raised to the power k divided by n raised to the power k? This gives n raised to the power k minus k, which is also equal to 1. So does this mean m minus m is equal to k minus k? Of course not. Remember that the two operations will not leave the same residue, even though whatever they leave behind is fit to be called 0. That is, m minus m is equal to epsilon 1, and k minus k is equal to epsilon 2. And epsilon 1 is different from epsilon 2, but about 0 because 0 is giving us the magnitude of 0 plus epsilon. Hope you get the idea. If not, please watch the video on 0 titled Why 0 Cannot Be Equal to Nothing for clarification. So we are maintaining the idea that anything minus itself is 0, but in this case, in a relative sense. If we let n to be equal to 0, we have 0 raised to the power m divided by 0 raised to the power m, and this is equal to 0 to the power m minus m. As we have seen, m minus m is equal to epsilon. So this is equal to 0 to the power of epsilon, or simply 0 to the power 0. From this relation, this should also be equal to 1. For m being well defined for any situation under consideration, or more specifically, for m equal to 1, 0 to the power m is equal to 0. So, 0 divided by 0 is equal to 1. Therefore, 0 divided by 0 is equal to 0 to the power 0. This holds true for any value of m, but note that 0 to the power n is not the same as 0 to the power m if n and m are different. That is a topic for another video. Please don't forget to subscribe. It is extremely important to pay very close attention to how 0 is defined. Otherwise, you will have things mixed up, which will result in paradoxes. Look at this expression, for example. If you are not careful, you may think that this is the same as 0 over 0 in the same way, so that it results to 1. But it is not so. Let's see how. From this expression, this equation can be written like so. This is equal to absolute 0 plus epsilon 1 over absolute 0 plus epsilon 2. Absolute 0 is equal to nothing, so it disappears, and we are left with epsilon 1 over epsilon 2. The two are different and so cannot cancel to give 1. But if it was 2 minus 2 divided by 2 minus 2, we would have ended up with the same epsilons, which give 1. If you enjoyed the video, please show your support by clicking on the like button. If you want to see more videos like this, please subscribe. Otherwise, it will be near impossible for you to locate updates on this development. Thanks for watching, and I hope I see you next time.